Okay, today we're going to put together the ideal gas law along with stoichiometry. Okay, we're going to deal with stoichiometry and gases. And we've done this before. But we did it before. It was always at STP. And at STP, it's really easy to do. Okay? The amount of gas is easy because at STP, you've picked a temperature, you've picked a pressure, so that moles and volume are tied together so that you can write 22.4 liters as 1 mole. So that you can change from moles of a gas to volume with a simple conversion factor. You just have to be willing to work in a really cold room. 0 degrees Celsius is cold. So today we're going to deal with what if you're not at STP? What do you do then? Well, it's the whole thing about chemical reactions. Chemical reactions happen in moles. So if I gave you liters, you could turn it to moles if you were at STP. Now, if they know how much gas, if they give me a volume, a temperature, and a pressure, I can turn that to moles. And they're going to have to give me all 3 of those if it's not at STP, because I need a temperature, I need a pressure, and I'm going to change the volume to moles. And I'm going to do that using the ideal gas law. Okay? So if they give you a volume to start with, you can turn it into moles and then do the stoichiometry problem. And if they ask you to figure out how much you made, use the moles to figure out the volume. Okay? Because I can solve PIV-NERT for volume as well. So basically the whole idea is you don't get to use 22.4 liters. Any place you'd want to use 22.42 liters, you have to stop and do an ideal gas law problem. So if you start off not at STP, you got to do an ideal gas law problem. If you end up not at STP, you got to do an ideal gas law problem. Let's work out a couple examples. Okay. So commercially, this is how they can make hydrochloric acid. They take some sodium chloride solution, mix it with some sulfuric acid, and you get a double replacement reaction. And it happens because this gas goes away. Okay. So we get a double replacement reaction that we know that happens. So what mass of NaCl is needed to produce 340 milliliters of HCl at STP? So they want mass of NaCl. So I know my answer needs to be grams NaCl, and they told me about milliliters of HCl, which is a gas, and it's at STP. So first of all, I know I can't work in milliliters. So to change that to liters, I move the decimal point over 3 times, and I get that it's 0.34 liters. And then I can just start off with 0.34 liters of HCl. And we've done lots of problems like this. You get rid of liters of HCl. You can go straight to moles of HCl because it's at STP, and 1 mole is 22.42 liters. Then you can do the stoichiometry part. Get rid of moles of HCl and change it into the chemical they asked about, which is moles of NaCl. And in my balanced equation, that's a 2 and a 2. And then turn moles of NaCl into grams of NaCl. And 1 mole for NaCl is 58.44 grams. Add those numbers up on the periodic table. So pushing these buttons, 0.34 divided by 22.42. I'm not pushing the 2's, times 2 divided by 2 times 58.44 gets me that this is 0.89, because there's only 2 sig figs, grams of NaCl. So pretty straightforward. Did those in the last chapter. So now let's look at that same question with a minor change. The change now is, it's the same question. We still got 340 milliliters of HCl, but now it doesn't say at 22.4, at STP, it says they give me a temperature and a pressure. So I've got a volume, a temperature, and a pressure, so I can find moles. PV doesn't want to write in that spot for me, so let me move over a little bit. PV equals nRT, and I want N, so I'm going to divide both sides by RT. So N equals PV over RT. The pressure was 1.51 atmospheres. The volume was 0.34 liters. Remember, I still have to work in liters because R has liters in it. And the R I want is the R in atmosphere, so 0.0821 liter atmosphere over moles in Kelvin. And the temperature was 20 degrees Celsius, which is 293 Kelvin. I'll push the buttons. 1.51 times 0.34 divided by 0.0821 divided by 293. And that equals 0.021, only two sig figs and 0.34. And what units? Well, the kelvins cancel out, the liters cancel out, the atmospheres cancel out, and I'm left with moles. And that's moles of HCl. And now that I've got 0.021 moles of HCl, I'm ready to do stoichiometry. So I'm going to get rid of moles of HCl, turn that into moles of what they asked for. And that was 2 and 2. And then, run out of room, so let me erase that last answer. Get rid of moles of NaCl and change it to grams of NaCl. And 1 mole is 58.44 grams. So I just got that answer in my calculator. I don't have to push the 2, so I'm just going to times 58.44, and I get 1.2 grams of NaCl. So these two examples, first one was at STP, the second one's not at STP. At STP, my first step was to go from liters to moles. And I could do that with a conversion factor. In the second step, my first step was to go to liters to moles, but I couldn't use that. I had to use PivNerd. So the idea is any place you want to use 22.4 liters, if you're not at STP, you need to stop and do an ideal gas law problem. Another example. Okay. So what volume? They want a volume of HCl. They gave me a temperature and a pressure, and they gave me the mass of NaCl. So I've got a temperature and pressure, and I want a volume. That means I need moles, but it's not, and I need moles of HCl, because that's what's going to be the gas. Gas laws only work if they're gases. So here I start off with the 10.2 grams of NaCl, the stuff they gave me. And I want to change chemicals, so I got to go from grams of NaCl to moles of NaCl. 1 mole is 58.44 grams. And then I can go from moles of NaCl to moles of HCl. That's 2 and 2 out of the balanced equation. And what you'd like to do is get rid of moles of HCl and turn it into liters of HCl, and you'd like to write 22.42 here, but you can't because you're not at STP, so you cannot do that conversion factor. You have to stop and figure out how many moles you have. So 10 10.2 divided by 58.44 is 0.175 moles of HCl. So now I've got moles, temperature, and pressure. So PV equals nRT. Solve that for V. So divide both sides by P. So V equals nRT over P, which was 0.175 moles. I use the moles of HCl times R. And since my pressure is in millimeters of mercury, I need to use 62.4 liters, millimeters of mercury over mole Kelvin divided by, I forgot the T, and the T was 298 K divided by P, which was 715 millimeters of mercury. And when I push those buttons, oops, 298 divided by 715 equals, and I got 4.55 in my units. Crossing out moles and Kelvin, I'm left with liters, which is good because I was looking for a volume. And that's how you do this. Good luck on tonight's homework. If you have questions, email me.